This is Core Connections Geometry Chapter 2, Angles and Measurement. Congruent means that two things are equals. For example, this angle is equal to this angle. These squares are equal to each other. They don't even have to be at the same rotation. For example, this square is equal to these two squares. And these lengths are equal to each other, therefore these two triangles are congruent to each other. Complementary angles add up to 90 degrees. In a situation like this, you can use complementary angles to figure out what x is. For instance, you know that this angle together must be 90 degrees, right? Because all the other angles are each 90 degrees. So you can find out x by subtracting your given angle, which is 67 degrees, from 90 degrees. So 90 minus 67 equals x. So that means x would have to be 23 degrees. Supplementary angles add up to 180 degrees. This means that if in a right triangle, you already know the angle of one of these, which is 90 degrees. So if you know the angle of another one of these, which we'll say is 32 degrees, then you can easily find out the measurement of this one using the supplementary thing. So 180 is supplementary because all triangles' angles add up to 180, minus this 90 degrees, minus 32 degrees equals this one. So this is 90 minus 32, which would have to be 58. When two lines intersect, vertical angles are the angles that are opposite of each other. Vertical angles are always congruent to each other. You can actually combine all three of these methods to figure out what the angle is of x in a situation like this. So for this one, I first use vertical angles to figure out that this is 64 degrees, right? Then I use complementary angles to figure out that this would have to be 90 minus 64, right? Which equals 26. So that would be 26 degrees. And then we have to use supplementary angles to figure out what this is, right? So 180 equals 26 plus 20 plus random variable y. So that would be 46 plus y equals 180. So you subtract 46 from each side, and then you have 134 equals y, right? So this is 134 degrees. But by using vertical angles, you can see that x is vertical to this, which means that x is also 134 degrees. A transversal line is a line that intersects two other lines. The triangle sum theory says that all angles of a triangle always have to add up to 180 degrees. This means that using two angles of a triangle, you can easily find out the third one. For instance, 180, which is the amount that all triangles add up to, minus 84, which is this, minus 40, which is this angle, equals x, which is this angle. So 180 minus 84 is 96. 96 minus 40 is 56, which is this angle right here. There are some other angle relationships that you should know. For instance, corresponding angles are interior and exterior angles on the same side of the transversal, and they're congruent to each other. Alternate interior angles are two interior angles that are opposite the transversal. That means that they're inside these two lines. Alternate exterior angles are two exterior angles that are opposite the transversal, which means that they're outside these two lines. And those are also congruent. Same side interior angles are angles that are interior and on the same side of the transversal, like these two. And they're supplementary, which means that they add up to 180 degrees. And same side exterior angles are also supplementary, and there are two exterior angles on the same side of the transversal. And just so you should know, vertex is the point of intersection between two lines. The area of a triangle is a half of its base times its height. Now the height is this thing here, it is not this thing here. And the area of a rectangle or a square is just base times its height, which is this times this. So the area of this triangle would be half of 6 times 9, which would be 3 times 9, which would be 27 units squared. And the area of this rectangle would be 6 times 2, which is 12 units squared. So with parallelograms, the way that you find the area is by multiplying the base by the height, like before, but what you need to remember is that this is the base, but this is the height. This is not the height. Now there are 2 ways of finding the area of trapezoids. One of them is to divide it into a rectangle and 2 triangles, as I did here. As you can see, the base is 5, but the other base is 3. So that would mean that this is 3, but this measure is 1, and this one's 1. So that would have to be 1 unit squared, and then 3 times 2 is 6. So it would have to be 8 units squared. The other method is to take this trapezoid and then make another one out of it and then flip it upside down, and now you've got a parallelogram. As long as you know the height, then you added these 2 measurements together of the first base and the second base, and this is 8. So this would be 8, and this is 2, so 8 times 2, 16. But remember to divide your final product by 2, or else you'll get double the amount that you had before, because of course you have 2 trapezoids. So what you do if one of these things is a binomial, and a binomial is something with 2 terms. So you use this thing in which you cut a square into 4 pieces. So you take the numbers of the first expression, which is 7x, and 5. You don't have to worry about the plus, that just means it's positive 5. And the numbers from the second expression, which is 4x and 3. And then you multiply this together. You multiply this and this, you multiply this and this, and you multiply this and this. So this and this, 5 and 3 would be 15. 7x times 4x is 28x squared. 20x, 21x, and then you add all of this together. So you would get 28x squared plus 41x plus 15. And that would be the answer to this. And you can put these 2 formulas together to figure out the area of giant figures like this. So 3 times 2 is 6, divided by 2 is 3. And then you subtract, you do 5 minus 3 to get this. So this is 2. And then this would also have to be 2, because this is 2, and the length of this whole thing is 4. So 2 times 2 is 4. And this bottom part is 5, and then this part is 2. So 5 times 2 is 10. And then you just add them all together. So 3 plus 4 is 7, and 7 plus 10 is 17. So the area of the whole thing would have to be 17 units squared. So the Pythagorean theorem says that in a right triangle, a squared plus b squared is c squared. So a squared can be this or this. It has to be either one of the legs. The legs are the things that are next to the right angle, and the hypotenuse is the one that's across from it. So this can be A or B, and this one can be A or B, but they can't be both A or both B, and this would be C. You can use this as an example. So 5 squared plus 3 squared equals x squared. So 5 squared is 25, 3 squared is 9, and then x squared we don't know yet. So 34 equals x squared. So then you take the square root of both of the sides. So x would have to be square root of 34. I hope this was informative.